In this example, we have the power series of x to the n dividing by x plus 2 factorial, and we want to find the interval convergence. What interval convergence is just the set of x values for which this power series converges. And one more time, the difference between a regular infinite series and a power series is that in the power series we have the x and the n. In the regular infinite series, we just have n. And so to find the interval convergence, then we will use the ratio test to find the ratio of similar to this, and then set it to be less than 1. And so first, we let, instead of base of n, we'll use u sub n for power series. Be this. And then we need to form u sub n plus 1. And u sub n plus 1, we just replace n with n plus 1. So replace this n right here plus 1, and then replace this n plus 1. And so now we end up with x sub n plus 1 is the same as x to the n times x to the first, and then this becomes n plus 3. And then now we need the ratio so instead of a, now we have u. And then u sub n plus 1 is this. And then u sub n is this. And then notice right here we have x sub n, that will drop out, they will cancel out. And so what's left for the top is just x divided by n plus 3 factorial. And then right here, nothing here, we put a 1. And so right here, this we get x. And then for the bottom, so x sub n canceled out. And so there's nothing here, so we put a 1. And then this becomes this. And so it would be x over n plus 3 factorial, and then times dividing by 1 over n plus 2 factorial is the same as multiplying the reciprocal. So it will be n plus 2 factorial dividing by 1. And then let's rearrange this like this. So we'll move this over here, and then we'll put the x over here. And then this becomes, we can separate them like this. And then now we need to simplify this part. N plus 2 factorial, it just means n plus 2. And then subtract 1, we get n plus 1. And then subtract 1, we get n. And then subtract 1, we get n minus 1. And then eventually it will come down to 3, 2, and 1. And then the difference between n plus 2 and n plus 3 factorial. And so here we need to start with n plus 3. So that's the difference. And then we can see that all of this will cancel out with all of this. And so nothing left on the top, we get a 1. And on the bottom we have n plus 3. So one more time, all of this will cancel out with all of this. And nothing left on the top, so we have a 1. And so now let's go back to our ratio right here. So this becomes 1 over n plus 3. And we want the limit of this thing. And so this becomes the limit of this. And then if we want, we can also rewrite this. So this is limit separately like this. As n approaches infinity, we get 1 over infinity, which is 0, and then times the absolute, this is limit with respect to n, but there's no n here. And so this be just absolute value of x, which is equal to 0. And recall that with the ratio test, the regular infinite series converges if the limit of a sub n plus 1 dividing by a sub n is less than 1. But here we have the limit of u sub n plus 1 dividing by u sub n is equal to 0, which means that it's already less than 1. And so the limit is equal to 0, which is less than 1 for any x. So what that means is this power series converges for any x. And therefore, interval of convergence is negative infinity to positive infinity. So for this power series right here, put any number in the place of x, and this series converges any number. So anytime we have the limit of u sub n plus 1 divided by u sub n, if it's equal to 0, then the interval convergence is going to be negative infinity to positive infinity.